Glad you told me now. So the question, what is the ratio of T2 to T1? That's what they wanted. Well, T1 is mu times V1 squared. Mu is mu, and V1 is what? 10 meters per second squared. 100 times mu. T2, it's mu times the velocity 2 squared. Again, mu didn't change. The velocity is what? 23 squared. My calculator will say what? (23 squared is 529. So the question, what's the ratio of T2 to T1? Was 529 mu over 100 mu. What happens to the mu's? Cancels out. So the ratio is what? 5.29. And express answer to significant figures, 5.3. So the tension T2 has to be 5.3 times stronger than tension 1. That's what that means. But they're looking for the 5.3. They're looking for the ratio of T2 to T1. But that's what that means. You want this, the tension on that string to be 5.5, a little bit, almost 5.5 times more tight than T1. Correct. So that was number 13. Let's look at number 23, the next one on the list. Let me find that. Oh, they're giving us a periodic wave. If a wave, so number 23, if a wave on a string is described by the equation y equals 18, that's in centimeters, 18 cosine pi, God, my eyes are horrible. I think in the bottom here, it's 4.3 centimeters times x minus I can't see it if that's centimeters or meters. Let me just see. Minus pi over 15 seconds t. This is in centimeter because you want this in centimeters, and this is in second because time in second, that's why. What is the amplitude? The amplitude is the height of it, how high if you graph that sine wave, if I can graph it, it will look like this. It's a cosine wave, not a sine wave. The standard cosine function, the standard, is, it will look like this. That's just the basic cosine function. And the height is 1. The lowest value is -1. So my amplitude is 1. From the center to the peak value, not peak to peak, from the center to the peak. And this would have been 2 pi, this would have been a pi. That's the standard cosine function. This one actually has a little shift in it. Instead of starting at the peak right there, this particular one is actually shifted. So the peak value might be here. The maximum height, it will go to 18 centimeters because the 18 in the front, and the lowest value is negative 18. Why? Because a cosine function, the largest value for a sine or a cosine is 1. So 1 times the 18 is 18. And my amplitude here is actually 18. From math, we used to write the function like this. Just a quick review in math. We go the amplitude as the height. It is the absolute value of A. A is 18. What's the absolute value of 18 here? 18. The period, how long it takes it to complete one full cycle. It's always 2 pi divided by that number, B. And the shift, notice this doesn't peak at the 0. It's backward. It's always minus C over B. Negative this value over that value. Actually, the one I drew that was a minus, it should start on the right side. My mistake. So this actually will start the peak on the right side, not on the left side for this one. So it will look like this. The peak will be on this side, on the right side, not on the left side. It's minus, that's a negative number, makes it this over this, that's a plus value on the right side. So it's going to peak on the right side of it, based on that equation. So the first question, can you tell me what the amplitude is? And the amplitude is 18 centimeters. That's the number in the front. The next one is, what is lambda? Well, we said a periodic function. Let me go back to your note and pull that. Maybe we can find it. A periodic function has the standard notation of what? Let me write it down. It is a cosine 2 pi over lambda. So there's my function. And again, the standard one, the standard form for a periodic function is a cosine 2 pi over lambda x minus 2 pi over t times t. So the next question they're asking us, what is lambda? So we know the amplitude A is the absolute value of 18, which is 18. This marker is dead. Go away. Now, how do we find lambda? Second question. Well, to find lambda, this piece has to equal to that. So we go pi over 4.3 equals 2 pi over lambda. For these to equal to each other, this number must equal to this must equal to this, and this must equal to this. Notice they both have, I'll leave lambda, but go cross multiply. Pi times lambda equals 2 pi times 4.3. What is lambda? 2 pi times 4.3 divided by pi. What will happen to pi? Gone. 2 times 4.3, which is what? 8.6. So what is lambda? 8.6. Submit. Correct. What is the period? What's t now? That's the next question. Set these guys equal to each other. Again, cross multiply. Pi times t equals 2 pi times 15. T equals 2 pi 15 over pi. And what will happen? Pi is gone. 2 times 15, which is 30 seconds. So the period for that should have been 30 seconds. And the next question is, or the last question, what is the speed? How fast that wave is traveling? Well, we know, I'll put it here, I have room for it. Question 4, velocity. We know velocity of a wave is lambda times what? F. And F equals 1 over t. So the velocity is lambda times 1 over t, which means what? Lambda over t. Do we know what lambda is? Right here, 8.3. Do we know what t is? Right here, 30. And what's the velocity? 8.3, oh, turn it on. 8.3 divided by 30, 0.28. This was centimeter per second. Remember, this was in centimeter, it wasn't meter. So 0.28 centimeters per second. Is the unit in centimeter per second or meter per second? Centimeter per second, yep. It says try again. 8.3. Double check my numbers. Divide them again. 8.6. Sorry. Lambda is 8.6. I don't know where the 3 came from. Is there a 3 anywhere in the problem even? .6. 0.29. Let's try another 0.29. The 0.28 was a little bit high. Backspace, delete it. 0.29. Correct. Then high mom in the bottom. For the new ones to us, essay ones, just leave them alone. You can write anything you want to write. I didn't even get them. Excuse me. That's 23. By the way, the lambda, we know that's the wavelength. T is actually how long, time-wise, it takes to complete one full cycle. So if you're watching that wave, where was it? Like this one, there's a good picture. Or it could be that picture. Doesn't matter. To start one full cycle from the beginning to the end, from here back to repeat itself, it takes 30 seconds. That's what that means there. So if you're watching the peak travel and go in this direction, if you're just looking at the peak, you'll see the peak moving in the lab. And the speed it's moving, it's roughly 0.29 centimeters per second. It's really slow. Next question is number 40. 31, 26, 27, 40. Human eardrum. So this is number 40. The human eardrum has a, what is it? Has a radius. So assume the human eardrum is like round, like this. And the radius of that is 4.3 millimeters. You got to divide it by 1,000 to get it in meters. You got to divide it by 10 to get it in centimeters. Find the energy per second received by the eardrum. When the listening sound, the energy per second, we're looking for the energy. When the noise is the threshold, and in case you forgot, we have to look at that number for the threshold. The threshold is 10 to the minus 12. Again, we're looking for, let me go back. Find the energy per second. Energy per second. I. Okay. We know I equals P divided, by A. We know what I is here. We're looking for I. We know I at that one. We're looking for P. I don't know why I use E. We're using P here. Remember, energy per second is called what? Isn't that power? Isn't it energy per second? So energy per second. Let me just write it there. That's actually the power, because power equals E over T. We can go back to chapter 8, whatever, 9. Power is the energy divided by the time. How much energy per second? So looking for the power, really. That's what they're looking for. I have one equation that has I and P in it. If I remember, I equals P over A, which means P equals I times A. And the area, it's pi r squared. Remember, we're dealing with a 3-dimension. The ear, just like anything else, when you make a noise, the noise travels like a basketball, spherical shape. And the area for that, pi r squared. So this is going to be I times pi r squared. I is what? 10 to the negative 12 times pi times r, which is I got to convert that to a meter, and that number is what? Get divided by 1,000. 0.00, I think 43 squared. Divided by 1,000. Millimeters to meters. 4.3 divided by 1,000, just to make sure that number is correct. 0.0043, square it, times pi, times 1 e to the negative 12. And I got 5.81 times 10 to the negative 17. Energy. per second. Joules per second. What's joules per second? There's a different name for it. That's watts. Now the second part, we'll come back and plug them in. The second part of the question, find the energy per second, the eardrum, if the listening sound, that is a threshold of pain. A threshold of pain. So we need that chart. I don't have it with me. The beginning pain, was it 120 decibel? What is it? 120? Yep. At 120 decibel, that's the threshold for pain. Pain is 120 decibel. And I gotta look and see again. We're looking for P. P equals I times A. I don't look at the unit for that. So let me see how they want the answer, what unit. So let me answer the first question, part A. They want it in watts. Does it use two significant digits? Two significant digits. So the first one would be 5.8 10 to the minus 17. 5.8 times 5.8 10 to the power of, we said negative 17. Submit in watts. We got it right. Now the second one, we need to figure what that number is in watts. 120 decibel. Now let's see what decibel. How do we calculate decibels? The log, what's the number before the log?
110.
What is it?
110?
No.
110 log?
You had poppers, right?
10 log?
10 log. 10 log of that number. So the 120 is going to be 10 log of that number, which is I. If you divide by 10, you have 12 equals log I. And to get I, you take the inverse log, which is 10 to the power of 12. The inverse of the log gets 10 to the power. So 10 to the power 12 is actually what the value is. So now you plug it in times the area. So it'll be 10 to the 12 times pi times 0.0043 squared. 1 e to the 12 times pi times 0.0043 squared, which is 5.8 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, I think, watts. It looks like they want the answer in watts. They don't want it in decibels or any of the other stuff here. 5.8 10 to the power of We said what, 7? Let me just look at the question. We got it wrong here. Let's see. The math is correct, but how they want the answer? Find the energy per second received when students. Because a lot of times for the threshold of pain, they use I equals to 1. That's the threshold of pain. I equals to 1. So if we put I equals to 1 here, because I put that real number there, let's try 1 here. Threshold of pain, I equals to 1. So you do that, what do we have for a number? Pi times 0.0043 squared.
Why did you?
5.8 times 10 to the negative 5. A lot of times in physics book they use the threshold of pain is 1, not the 120, the threshold of pain. The other one is pain, but the beginning of the threshold of pain, I is 1. See pain here, it says starts, where's that chart? So I bet you that's what they're going to use. Instead of being 120 decibel, they're not defining pain as 120 decibel. The threshold, the beginning of pain, you start to feel pain when I equals 1. So it'll be a negative 5. So I bet you the beginning of the pain starts at that number, a lower value, and start to increase beyond that. But that's the beginning where the beginning of it, I equals to 1. So let's try that number, 5.8. Try that number, negative 5. At that value, definitely, that might be a rupture, the I equals 120. Is that a rupture? What is that chart? 14? That was correct, by the way. Chapter 14. I think the 120 decibel when eardrum rupture, I think. Or I don't know. Let me see that chart. Where is it? I can't remember that chart for all. Where was it? 13. Let's go 14. Oh, I get the wrong book. That's why I'm seeing these shapes of calculus. Nothing matching. I'm looking at it like, wow, nothing's matching. Okay. Chapter 13. Where's 14? Let's look at the chart for the decibel and see what the value. Right here. I was right. Threshold of pain. See that? I equals to 1. It's in the book there. We know I was looking at the decibel here.
Are you going to give us?
You get this chart, yeah. It says pain here, 120. It didn't say the threshold of pain, not the beginning of it. At 120 decibel, you are feeling discomfort, pain. But the beginning of the pain begin actually a lower value. So that's what the threshold, where does the pain start? At 120, definitely your ears are hurting. They're going to start feeling bad at when I equals to 1. So that's why that first number wasn't right. Pain 120 decibel, that's correct, but the threshold of pain begins at I equals to 1. That's a negative 5 here. That was 40. 50. I found 50. Here we go. Number 50. It says, hearing the siren of approaching fire truck. This is the fire truck. There's the siren going. There's the ladder on the roof of the truck. The fire truck is moving this way. You pull over the side of the road and stop. That's you. You, the receiver. You stop. Not moving. The source is moving. The source, the siren is moving. You are the receiver is not moving. As the truck approaches, you hear a tone of 460 hertz. That's what you're hearing here. The frequency you're hearing, 460 hertz. As the truck recedes you, you later hear a tone. So now the truck passed you, you still stopped here. That's you. Still stop. And the siren now is right here. Now you hear the frequency, we'll call F prime, that's what you're hearing. It's 410 hertz. And the question is, how much, time-wise, how much time? How much time? As the truck recedes you, okay, maybe I drew the picture wrong here. As the truck recedes, what does that mean?
Going away, I think, receding.
Okay. You hear the siren, 410. How much time? I didn't know if like they meant that when the truck is right here at 410 or even past you already. The 410, I'm not sure if they meant it when the truck is here or has already passed you. You know? So we'll see what that number is. I think when the truck right next to you, I think that's what they're implying. We'll research that in a minute. How much time is required, because it truck's from your position to 6 kilometers away. If there's a fire, how long would it take? If the fire, here's the fire is 6 kilometers away from you. A 6 or 0.6? A 6 kilometer. Well, if the truck already passed you, we have no idea how far the truck away from you. So I think what they're implying, the 410, when the truck is right next to you. I think that's what the implication of that problem. Otherwise, where is the truck in relation to you? If you are 6 kilometers from the fire, where is the truck? Is the truck 1 mile ahead already, half a mile, 3/4 of a mile? That will determine. So I think what they meant by the 410, when the truck at your car recedes. Anyone heard that word you've been used before in this example, recedes? It's my first time hearing it here. But I think the truck for this example was like right there. That's where that number, not down here. They should just, when the truck passes you, make sense here, you know. Because now we know the truck is also what? We know the truck is 6 kilometers away from the fire. So that's the reason I'm thinking that's what they meant. How much time is going to be required of the truck to get to that fire? Which means I need to know what is the speed of that truck. Because if I know the speed of it, I know the distance. Time is what? Distance divided by speed. Maybe it was ahead. I don't know. Receipts to me wasn't like even with you.
Well, the definition is to go or move back or further away from the previous position.
Previous position. So, should we make assumptions already there? Go back to that and see if we can solve it that way?
Are we just using it to find the velocity?
Yep.
So we can just find
Yep.
the-
Yep.
I think he's just doing it in relation to you.
Okay. Okay. Let's put the truck here, huh? Let's see if it works out that way. Because it doesn't matter where the truck is. His sound will tell us, actually. We know that how fast the sound is traveling there, the siren, what V is. Let's see. Let's see if it can be done that way. We need to know what U is. I'm not really clear if the truck already passed me or by me. I'll make the assumptions right here. I'm not sure. If it doesn't work out, I'll come back and make the assumptions here. My only problem is, as I said, how far is it ahead of me? That's what's bugging me, like I'm not sure where, but that's okay. Let's wait and see. And I can tell you, when I make a question like this, in my mind, I have a clear picture what the question is. So I'm not defending them, but when someone writes a problem like this, they have a story in their mind, and they don't think what other people might see it. So when I make a test question, sometimes in my mind, I have this picture. I go, this is the problem. Someone said to me, did you mean this or that? I go, that thought never once crossed my mind. So now I have to explain to people, no, I meant it this way. So let's see, let's assume the truck is there. We'll look at it two cases. Before the truck comes here, when it's behind you, well, the frequency when it's from behind approaching you, if you remember, it is what? V over, I can look at it two ways, V minus U times F, or we used to say what? 1 over 1 minus U over V times F. We're going to use that when it's approaching you. When it's going away from you, passing you like this example here, is going to be the reverse. It's V over V plus U times F, or 1 over 1 plus. Oh, the F is high. It's not that low, the F. It's on the top of the fraction. If I actually take this equation and solve it for F, I'll take both of these, solve them for F. This one I will have F equals V minus U over V times F bar. We're solving for F, for that F, not this F. V minus U over V times F bar. And if I solve this for F, I'm going to have V plus U over V times F bar. Well, F is the same. That's the frequency of the siren of the fire truck. V is the speed of sound, which is what? What's the speed of sound? Is it 343?
Yeah.
343 minus U over 343 times the first frequency. And the frequency when it was approaching you, the problem says what? You see, you heard the frequency to be 410 equals 343 plus U over 343 times the frequency, 460, I'm sorry, the first one is 460. When it's approaching you, when it's going away from you is what? 410. I can multiply both sides of the equation by 343. These will cancel each other out. That's 460 here. So 460 times 343 minus U equals 410 times 343 plus U. We should be able to solve it for U here. So 460 times 343, 157,780 minus 460 times U equals 410 times 343, 140,630 plus 410U. Move this one to this side. Move this one to this side. 870U, that becomes a plus, equals 17150. What is the speed of the fire truck? 1715 divided by 870, roughly 19.7 meters per second. Let's assume the truck wasn't really that far away from you, just past you. Because if it's too far, the time, because the question is, how far, how long will it take? Well, from your car, we can calculate the time. If the truck was your car, because we know how fast it's moving. We know the speed of the truck, and we know actually what the distance is. So the time, it's distance divided by velocity. The distance is what? 6 kilometers, that's 6,000 meters. And the speed is 19.7. It's going to take 304 seconds. Let's see if that's, again, making the assumption here, the truck is not much ahead of you. Because if the truck traveled already farther there, it might be at the fire by that time. Let's see if that's the correct answer. Two significant figures, that would be what? 300? 3.0? 300 seconds. Correct. Again, the assumption made here, the siren was right here. There's you. And the truck now is past you there, but it's really not that much ahead of you. Because otherwise, that time will not be the same time as here. If it was down here and the fire is here, if the truck was next to the fire, it will not take that time. It's from you, if you were going from here, at that speed will take you 54 seconds. At that speed. How much time will it take the truck to get from your position? Oh, from my position. So it doesn't really matter where the truck is. It says how much time will it take the truck to get from my position, from where I was, to get there. Then that doesn't matter where the truck in relation is. I thought it was from the current position where the truck at. No, it says from my car as it passed me. How long would it take them? 300 seconds. I just didn't read that, from my position. How much would it take the truck to get from your position to the fire? So then their question's clear. I just misread it. Okay, 48. Uh-oh. We have a motorcycle. This is number 48. We didn't put them in order. We have a police car. It says police on it. And it's moving this way. We have a motorcycle here. He's going this way. Mu for the source, mu for the object. The receiver is moving, the source is moving. Both are moving. The frequency of the police car, it's 502 hertz. And the speed is 26. This is mu s is 26. The motorcycle is moving at 12. What frequency does the motorcycle hear? What's f prime? So here both are moving. The source is moving and the object is moving. The source is moving and the object is moving. Since the source is moving toward you, the frequency and the object is moving toward you, we need to use this equation. 1 plus mu object over v over 1 minus mu source over v. I gave you these equations last time. The source is moving toward you, that's where the minus sign comes in because it's going to be quicker. The object is moving toward you, that's why this plus is going to be quicker too. If they're going away from each other, the plus will be in the bottom, the minus will be on the top. So what's the frequency? So this will be 1 plus, I could have made a u, you know what? I like it this way. Multiply by v. I don't like these fractions. I don't know why the book is a big fan of fractions. Multiply by v. You'll have what? The top and the bottom. V plus u bar over v minus mu s. That looks a little bit nicer, actually. I don't know why they make it worse there. If you multiply the top and the bottom by v, you end up with that. 343 plus the 12 over 343 minus the 26 times the 502. $343 plus 12 divided by parentheses 343 minus 26 close parentheses, and you multiply that number by 502. 562. So let's see, is it two significant digits? 560 if it's two significant digits. Doesn't say anything. Since the numbers are three significant digits, I'll write three significant. 562. Submit. Correct. Okay. 52 is the last one. A particular jet engine produces a tone of 495 hertz. So the frequency is 495. Suppose that one jet is at rest at the on the tarmac. Here we go. There's a plane on the runway. Right before you take off. The tires here on the ground. So the velocity is 0. That's mu is 0 for this one. Running, but take off there. While a second identical jet, the same frequency, flies overhead at 83.8% of speed of sound. So we have a jet flying by toward each other, away from each other. Does it say? Assume the moving jet is headed toward the stationary jet. Okay, on the bottom says that. So the moving jet is, so this is flying, has also a frequency of 495. This is an identical jet. But it has a speed here, which is 83.8% the speed of sound. Well, that's V. Well, 83.8%, I should say percent, times the speed of sound. The pilot of each jet listen to the sound produced by the engine of the other jet. The first one is hi mom, okay. Gibberish right here. Let's see what the question is. Yep, go ahead. Calculate the frequency heard by the pilot of the moving jet. Moving jet. What this one's going to hear is the sound from this one. So this one, the source is not moving. This one's going to hear, he's moving, the object is moving, the source is not moving. This one is going to hear the engine of that plane. Now, this one is what? The object, the source is moving, the object is not, so reverse. So that's what's happening. So we're going to do it twice. Each one of them, one the source moving, the other one the object is moving. So the speed of this aircraft is 0.838 times 343. And what's that number? 0.838 times 343. This moves at 287 miles per hour. Or meters per second, I'm sorry, not miles per hour, meters per second. 287.4, if you want a decimal place.
And why did you do that?
It says the speed is 83% of V, speed of sound.
Why do you times it by 3?
Speed of sound, 343. Speed of sound's wave is 343 meters per second in air. That's why. The moving pilot. Let's say with the moving pilot. F prime is the frequency heard by the moving pilot. So if the pilot is moving, he's listening to that engine from this one. So we have source is not moving. Source is not moving. Object is moving. The source is not moving, but the object is moving. The frequency for that, f prime, is going to be v plus u times f, or 1 plus u over v times f. Here the source is not moving, the object is moving. This is the boombox sitting on the bench and a skater or a bicycle going by. That's what we did yesterday. So the frequency here will be 343 plus 287 times f, which is 495. Plus the 287 times the 495. Uh-oh. 343, I don't think I did it right. Plus the 287 over v, I'm sorry. Something is not right. It's like this equation is not right. That's over v, mathematically. It's this one correct. Multiply both sides. Top, this is v over v, so it's v plus u over v. I'm saying something didn't look right. Divide that by 343, which is 1.8 times the 495. So the frequency is about 909 hertz. Let's see if that's correct. $909. Does it say how many decimal places? Doesn't. 909. Submit. Correct. Now the second part, the frequency heard by the pilot of the stationary jet. They're not moving. Pilot. The one on the ground. So he's going to hear the engine of that plane, the plane flying. So the source is moving. Object is not moving. So the source is moving, but the object is not moving here. So the equation for that, f prime, is going to be v over. It's coming toward u, so it's v minus u. If it was going away, it would be v plus u. Just like this one, because they're approaching each other as a plus. If it was going away, it would be a minus here. Or you might see that looking like this in our book. 1 over 1 minus u over v. Doesn't really matter which way. I like this better. 343 over 343 minus, what was it, 287? Times the 495. $343 minus 287. 343 divided by times 495. I got a big number here. I got 3031. Seems a little bit high. Did I plug in anything wrong here? Let me see. Just seems a little bit high. 3030. It is correct. Just seems like a high number, high frequency. So two stories, you gotta look at it. Which one's moving, which one's not, who's listening to what. If this one is listening to the noise from this, the source is not moving, the object is moving. If this one listening to the engine from that, the source is moving, the object is not, the equations are different. And again, the equation could be plus or minus depending if it's going toward you or going away from you. Toward you or away from you, in both cases. If this was going away from you, this would be a minus, and this would be a plus if they were going away from each other.